Let's continue our math adventure. Today, we are learning how to add and subtract fractions. Now, when we go to add and subtract fractions, our life is made easy if our denominators are the same. Because if we think about what the denominator tells us, it tells us that if we take a whole thing, think of this as like a chocolate bar, and we divide it into 4 pieces, all 4 pieces have to be the equal size. And so that's what our denominator is doing. Our numerator tells us how many of those pieces we're looking at. So if I take a look at the 1/4, I'm looking at 1 of those 4 pieces. If I'm looking at the 2/4, I'm looking at 2 of those 4 pieces. And in order for us to add them, as long as my pieces are the same size, all I need to do is keep that denominator the same, but change the numerator to 1 plus 2, which is 3/4. So our life is easy if our denominators are the same. Where it gets a little harder is when we're going to start to add in those negative fractions. Now, we've already learned in the past when we were working with our integers that we can change any subtraction problem to plus the opposite. And if we do that, for a lot of people, it makes it easier for them to see their positives and their negatives. So I always follow that rule. So when I see a equation and it has subtraction in it, my first instinct is go and rewrite that equation to make it plus the opposite. Now remember, the first number always stays the same. But then I'm going to take my subtraction, change it to plus, but whatever immediately follows it has to go to its opposite. So if I cover up that subtraction, I can see that's a positive 5/8. So I want to change it to a negative 5/8. Now, all this does is it helps me see my positives and my negatives. And I know that positives and negatives can cancel each other out. So when I look here, I know this is positive. I always think of those as my blacks. But when I look here, I see that's negative. Well, I think of that as a different color because I'm trying to see that canceling out. So I'm going to say these are my blues. Now notice my denominator is the same. It means my bar has been cut into 8 equal sized pieces. I don't need to worry about that. So I can literally just bring that 8 over and it just stays there. Now I'm going to look at my numerators and I'm going to go back to what I've learned about integers and I'm going to draw out what I see. I see 3 positives, so I'm going to make those 3 black circles. And I see 5 negatives. Okay, I know that a positive and a negative cancels each other out. So I'm just going to draw a line through the ones that are canceling. Whatever is left, that becomes my new numerator. And I see that I have 2 blues left, and those blues represent my negatives. So I know that's got to be a -2 for my numerator. Now, just like with any other fractions, I always have to look at it and think, am I in lowest terms? And when I look here, I can see I could divide both of these by 2. That negative still follows it because it's just a negative rational number. 2 divided by 2 is 1. 8 divided by 2 is 4. That would become my answer. So it's a bit more complicated, but if we use what we've learned with integers, it should make it a lot easier for us to see. Now, sometimes we're also going to have mixed numbers. And again, if I see a negative or a subtraction, I got to stop and think, should I change that to plus the opposite? Well, I see -3 and 7/16 minus, I stop right there. And I'm going to rewrite that, keeping the first number the same, change that subtraction to plus, cover up that subtraction, see if it's a positive or a negative following it. That's a positive 8 and 11/16. I'm going to make that a negative 8 and 11/16. Now, it just helps me see what I'm working with for my positives and my negatives. Now, I solve mixed numbers a little differently in that I keep all my whole numbers with my whole numbers, all my fractions with my fractions. And so I'm going to draw a line to separate the two. And I'm going to rewrite this. So I see -3 and 7/16. And remember, that's also negative because it's all one number. And I see -8 and 11/16. Now, I changed this to an addition problem. So I'm going to add that. So always keep your whole numbers with your whole numbers and your fractions with your fractions. Now, when I look at this, I see everything is negative, so nothing's going to be canceled out. So all I have to do is bring down that denominator of 16, because that's never going to change. It's just I have 16 equal-sized pieces. And now I know this is going to be negative, and I do 7 plus 11, which is 18. Well, instantly, I see that numerator is bigger than my denominator. So I'm going to need to change it from an improper fraction to a mixed number. And that's really just a division problem. So I'm going to put my numerator on the inside. I'm going to put my denominator on the outside. And 16 can go into 18 one time, because that's 16. And I have 2 left. Okay, that 2 becomes my new numerator. So I'm changing this to -1 and 2, and I always go over that 16 because that's the size of my pieces. And I can reduce that by dividing by 2, so I get -1 and 1/8. Now I'm not done because I never looked at my whole numbers. So I have -3 plus -8, that's -11. Now I have to put those whole numbers and those fractions back together again. So I'm just going to take my -11 and add it to my -1 and 1/8. So my final answer is -12 and 1/8. Seems complicated, but if you follow the steps, it always makes it a lot easier. Okay, but we also know that we're having some variables come in, but nothing changes with fractions. So I always look at those denominators, they're the same, and that's all I want is same size denominators. So I'm just going to bring that denominator over. Now, I have 3 A's. All it's telling me is those A's are just like those long pieces. I have 3 of those long pieces, which are my variables in my algebraic tiles, and I have 5 of those long pieces. And they're all the same color. So in order to put it together, the long pieces don't change. They're still just going to be A's, but I want to know how many of those A's I have. Well, I have 3 plus 5, which is 8. Now, just like in all the other fractions, I have to see, can I reduce it? And I only look at the numbers for that. And I can see, well, I could divide by 4 on the top and 4 on the bottom. Because 8 divided by 4 is 2, but I can't forget the A. I put the A in. And 20 divided by 4 is 5. So that becomes my answer, and I leave it at that. It is a challenge to work with negative numbers, but I know you're up for it. Get to work.